Hi guys, and welcome back. We are moving on with proofs in chapter 2. And in this section we are going to write 2-column proofs for segments. But let's go ahead and make sure we review to make sure we remember how to do a algebraic proof. So let's take a look at what we have. We have 3 times x, or excuse me, 2x plus 6 plus 5x minus equals negative 4. So let's go ahead. First thing we always do with any kind of proof is write down the information that's given to us. So I'm going to write it down exactly how it is on here. Okay, so I'm going to have 3 times 2x plus 6 plus 5x equals negative 4. And that's given. Okay, the first thing that I'm going to do, I notice there's the distributive property that I need to use. So I'm going to say multiply that 3 all the way through. So I'd have 6x plus 18 plus 5x equals negative 4. And what I did there was I did the distributive property. Okay, so now I'm looking, I have some like terms that I can combine here. So 6x and 5x is 11x plus 18 equals negative 4. And the reason that we can do that is actually called combine like terms. I talked a little bit about that in the last video. Okay, and the next thing I'm going to do, I have 11x plus 18. I want to get rid of that plus 18, so I'm going to subtract 18 from both sides. And that leaves me with 11x equals negative 22. And what did I do there? I subtracted, so that's the subtraction property. And then my last step, of course, is I'm going to divide by 11 on both sides, and I get that x equals negative 2. And I did that by dividing, so that's the division property. Now we are going to take this idea of 2-column proofs and we are going to use segments instead of equations. So there's some things that we need to remember before we do that. So let's take a look. Okay, so some things about segments, okay, is you can use the properties that you used in algebra with segments also. Like you can add segment pieces together to equal a whole. So like on this first example, we are going to use the segment addition property. Okay, that property says I can take 2 pieces of a segment, add them together, and it will equal the whole segment. Okay, so what that means is I can take the whole segment will equal the part plus the part. Okay, so anytime you're given a segment and there's a point somewhere in the middle, so we've got these points here. We don't know anything about where on the segment B is at. We know that B is on segment AC, but that is all we really know. Okay, so all we can really say about that is I know that if I take the part plus the part, it will equal the whole. So when you're looking at your diagram or anything like that, if you are given a segment with a point on it, a segment that you don't know where that point is at on the segment, you can just add the 2 pieces together. So we can take and we can say that AC, the whole thing, equals the sum of its parts. So we can say AB plus BC. And the reason that we can do that, kind of like the addition property where we added the same thing to both sides, this is called segment addition. That basically says I'm taking 2 pieces of a segment, adding them together to get the whole. Okay, the other thing that you can do with a segment is if you know where that point B is at on the segment, so it tells you that B is the midpoint. Okay, so here's your segment, AC. You've got B is the midpoint, so we have A, C, and B is in the middle. It's at the midpoint. So some things that we can do before we start writing our proof is if I know it's the midpoint, then I know that this piece, AB, equals BC. And in geometry, we make those little tick marks on there to indicate that they are the same or congruent. So if we're going to use a midpoint, like it tells us it's the midpoint, it also might be called, other than midpoint, sometimes it's called a bisector. Or it might say that the point bisects the segment. That's the same idea. That's the same thing. It's telling you it's breaking it into 2 equal pieces. So the first thing that we would do is we could say that they tell us it is the midpoint. So if B is the midpoint, they tell us that, then, so it's those conditional statements, if B is the midpoint, then the two pieces are equal to each other. So we can make a statement, we can make a conclusion from that given information. So we could say that AB equals BC, and we always have to have a reason. Anytime you have a vocabulary word in your given information, like midpoint, the reason that you will give is because it is the definition of that vocabulary word. Okay? So these are some ideas that we're going to be using. All right, another thing that you can do, so these are just some properties that you're going to be using in your proofs that you're going to be doing today, is you can use substitution. Remember, substitution just means you can take out one thing and put something else in its place. So for instance, I have this segment AC here. Okay, so I have this whole segment. I don't know where B is at on that segment. It doesn't tell me it's in the middle. It doesn't tell me it's a midpoint or anything. So all I really know is if I am given this segment, I can look at the picture and say, that's one line, I can say that. You add the two parts together, it equals the whole. Okay, well, oh, we forgot to put our given information in there, didn't we? So we really should probably, this given should go right up above there, right in between the statements and that first thing, okay? So we would have that in there, and then we could say that, all right, we know AB equals 5. Put that in a different color. Okay, if AB equals 5, that means anywhere that I see an AB, I can take it out and put 5 in its place. We are just using substitution in order to do that. Okay, some other, I know this is a lot of properties, but you can always go back and refer to these later on. You can also use those properties of adding, subtracting, multiplying, and dividing segments. So you, as long as you are doing the same thing to both sides, say you have a segment addition equation here that's all with segments, it's not numbers, you can subtract a segment from both sides. It's still just doing the same, you're subtracting the same thing from both sides. So when I subtract BC from the left, it's gone, and now I just have oops, sorry. So now I just have AC minus BC. Okay, so we'll do that quite a bit in these proofs. The segment proofs are going to be a smidge bit harder than the algebraic proofs because there's a lot. Okay, so let's go ahead and start looking at a proof, okay? And a lot of times you will look at a proof and you'll say, well, I can see that that's true. I can see that if I have these two segments, they can be midpoints or something like that, or whatever it happens to be. But with these proofs, you have to go one step at a time and explain every thought process that you have. And there has to be a reason, a mathematical reason that you can do everything that you do. So as we're looking here, the first thing, okay, I have this whole segment. I have X, Z, there's my whole segment, and I've got Y in the middle. Okay, or it's Y is on the segment. So I look at my given information, okay, and it says that Y is the midpoint of XZ. So first things first, we always start with writing down our givens. So Y is the, I'm going to abbreviate midpoint MP of XZ, and that is given. Okay, that is all they tell us, okay? And what we're trying to figure out, our end game, is to show that it takes two XYs to make the entire segment, okay? So that's our goal. So we're thinking I need to eventually have that there are two XYs that you can put together to make the whole segment, okay? So let's start with our given. Well, we learned that if it is the midpoint, okay, that's our hypothesis. If it is the midpoint, then we know that it makes two equal segments. Okay, so we know that since Y is the midpoint, it breaks it into two equal pieces. So that will tell me that XY equals YZ. Okay, anytime we see a vocabulary word in our proofs, like midpoint, the reason that we can use that vocabulary word is just the definition of that vocabulary word. So that is just the definition of midpoint. Okay, so we have taken a given piece of information and we have made our own statement. Okay, so I'm saying that xy equals yz. Okay, again, keeping in mind my end goal is that I need to say that there are, if I can put two xy's together to make the whole statement, to make the whole segment. Okay, so let's think. Other than segments having a midpoint, the only other thing we really know about segments right now is that you can take the two parts and add them together to make the whole. So I know that I can take here, this part, here's my first part, plus my second part equals the whole thing. So okay, so we know that the two parts equal the whole. So let's go ahead and write that as a algebraic looking statement. We know that the whole thing, which is xy, or excuse me, xz, write my right letters here, xz, that's the whole thing, equals the sum of its parts, which is xy plus yz. Okay, how do we know that we can do that? That is just the segment addition. All right, so here it gets a little bit tricky, okay? So we have these two blue statements that I have highlighted in blue, and we need to combine those two statements to try to show what we are trying to prove right here, okay? Remember, we want xz, okay, we want xz to equal 2xy's, okay? Well, I know from the statement we made about midpoint that xy equals yz, which means anywhere I see a yz, I can take it out and put xy in its place. That's just substitution. So my next statement that I need to write is my whole thing, xz, I'm just going to rewrite that, equals xy, and now I'm going to take out this yz, and I'm going to replace it with xy, because it tells me xy equals yz, so they're interchangeable. So I'm going to take out that yz and put xy in its place. And the reason we can do that, we're just taking one thing out and putting another thing in its place, is called substitution. Okay, and then the last thing, we want to get 2xy. Okay, well, we know that xz equals, if we put one xy together and another xy together, we have two xy's. And just like we would have if it was like x plus x is 2x in variable terms, with segments we can do the same thing. That is just combining like terms. Okay, so that's looking at one example of how we can write a proof with segments. So if you need to go back and kind of listen to the reasoning or kind of pause the video and think about it a little bit, feel free to do that. Okay, here's another one. All right, this looks like, looking at what we have here, looks like it might have a little bit of algebra in it because it's got 7x and 3x plus 20 and things like that. And it also has some segment information about midpoint. Okay, so if you want to pause the video and kind of start and see where you think, if you think you know where you want to start and kind of get going and then listen to the video a little bit more, feel free to do that. Okay, so I have this segment, AC, from A to C, and we have point B in the middle. Okay, so right now I see a segment. So things in my mind that I'm thinking, do I know anything about a midpoint? Do I know anything about if I can use segment addition? Okay, those are things that are going through my mind. So I look at my given information. B is the midpoint of AC. Let's go ahead and write that. So B is, again, I'm going to abbreviate midpoint MP of AC. How do we know that? Because they tell us, so it's given. Okay. All right, so we take that piece of given information, and so if B is the midpoint of AC, then, it's just like every other time that we use midpoint, we see a vocabulary word, we can use its definition. The definition tells us that the two parts of that segment are going to be equal. So we can say that AB equals BC. That is just the definition of a midpoint. Okay, we still need to put our other given information in here, so let's go ahead and write those down. We have AB equals 7x, okay, and we also have BC equals 3x plus 20. And those are both given to us. Sometimes you have multiple things that are given. Okay, so now we look at what we have, and I notice I have an AB here and an AB here, which means any place I see an AB, I can take it out, and I can put 7x in its place. And I notice I also have BC here and BC here, which means anywhere there's a BC, we can take it out and put 3x plus 20 in its place. So if AB, which is 7x, taking out AB, and I'm using this equation right here, okay? AB, I'm taking out AB and calling it 7x, equals BC, well, we can take out BC and put 3x plus 20. And all we did was we took out a segment and substituted in an algebraic expression. So that's just going to be substitution. And from here, it's just an algebraic proof. Okay, so then we're just going to subtract 3x from both sides, and we get 4x equals 20. That's just subtraction because we subtracted from both sides. And I know some of you guys like to abbreviate, but if you notice, sometimes you have subtraction and sometimes you have substitution, so you can't just call it SUB, sub. You have to actually write a little bit more. And then in our last step, we divide both sides by 4, and we get that x equals 5. And how did we get to x equals 5? We divided. So that's the division property of equality. And once we get to where we want to be, we're done. Okay. All right, so here we have, again, it's another segment with point B somewhere in the middle. So here we have point A, point B, and point C. Okay, so I'm looking at it, and I notice my given information tells me that AC equals AB plus AB. Okay, it does not tell me that it is the midpoint. Okay, that given information, that is not the definition of a midpoint. The definition of a midpoint is that the two pieces of the segment are equal to each other. So we're going to have to work our way through to figure out how we can show that AB equals BC. Okay, so let's write our given information down. We know that AC equals AB plus AB. Okay, and that's given. Really, the only other thing definitions about segments that we've had so far is midpoint, and it does not say midpoint anywhere in the given information. There is no vocabulary word in there that says midpoint, so you cannot just say AB equals BC. Kids want to do that all the time. No vocabulary word that says midpoint, no definition of midpoint. Okay, so instead of midpoint, we're going to have to think, what's the other thing that we know how to do with segments, which is segment addition. So I can say that my whole segment, AC, equals the sum of its parts, which is AB plus BC. Okay, that's just segment addition. Okay, and, all right, so now we look, I've made this statement, and I notice things that my statements have in common. I have an AC here, and I have an AC here, which tells me anywhere I have an AC, I can take out, and I can put the other information in its place. So if I know that AC equals AB plus AB, anywhere I see an AC, I can take it out and put AB plus AB in its place. So I can say that AB plus AB, okay, I just took out this AC right here and substituted in what I know, equals AB plus BC. Okay, all I did was substitute. I took out AC and put those segments in its place. So that would just be substitution. Okay. All right, well, there's a whole bunch of ABs here in this statement that we have. And again, end game is I want to show that AB equals BC. And if you remember, just like when you can add and subtract numbers from both sides of an equation, you can add and subtract segments from both sides of an equation also. So if you note, I have an AB on each side. So if I subtract AB from over here and from over here, this AB cancels and this AB cancels. Okay, and I am left, all I'm left with on the left is AB. All I'm left with on the right is BC. And what did I do to get there? I just subtracted, so that's the subtraction property. Okay, these are better to do in groups, so I'm going to try to get you guys in some groups to work on some of these segment proofs for the rest of the period today. So I will have copies of proofs for you guys to work on and keep working on the logic and the reasoning on how you go from one step to the next, which is kind of hard when you're first starting out with it, but the more practice you do, the more you discuss it with your groups and with the teacher, the better you get at it. So good luck.